Welcome to Paving the Quantum Way. A warm welcome to all of you, wherever you hear us, wherever you see us, from Sweden to Spain, from Latvia to Luxembourg. My name is Katja Schleicher. I'm a communication coach and I consider myself a European, and I'm very happy that we today on this panel have gathered a wonderful group of people to talk about what quantum technology is going to mean over the next couple of years, during the next decade. We try to do that as practical as possible, and we try to inspire you as much as possible. In these times, it was not easy. This activity, Paving the Quantum Way, is kind of a roof for an activity that was called the Berlin Science Week. And in the Berlin Science Week, there is work with quantum technologists, quantum physicists for a whole long week. Unfortunately, due to the circumstances, that has not been taking place live this year, but virtually. We will talk about more in the second, and I have a wonderful panel together. My first guest comes to us from Italy, and it's Professor Chiara Macchiavello. And Chiara is kind of organizing and hosting all the European quantum technologies. And she is kind of chairman of the European flagship in that. So welcome, Chiara, welcome to Italy. My second guest is Dr. Markus Krutzik, quantum physicist, and awarded one of the top 40 under 40. And he's heading a very interesting and new activity with the Joint Lab of Quantum Sensors here in Berlin at the Humboldt-Universität. So welcome to the scientists of you. Thank you very much for being here. Next one, and I'm absolutely happy and pleased to have him here because this is for me the impersonification of somebody who does science and entrepreneurship. Dr. Jan Goetz is not just a quantum physicist, but he founded an enterprise. And hopefully we hear more from you of when are we getting quantum computers? What does it mean for industry? What does it mean to the people? Can we touch it? Can we feel it? How does it work? And most importantly, and the chairwoman of all these quantum activities here in Germany, I'm very happy to have her here, the German Minister of Education and Research, Anja Karliczek. Very warm welcome to you as well. It takes a lot of effort to put something on the agenda that does not seem a prior goal for many politicians. So I'm double and threefold happy that you're here with us to talk about that, and that is why the first word is yours.
Thank you. But it's a prior goal for us.
Vielen Dank, aber das ist natürlich für uns ein prioritäres Ziel. Dear researchers, ladies and gentlemen, dear participants of the Quantum Future Academy, I'm very pleased to welcome you to the Quantum Future Academy 2020, because here at the FUTURIUM in Berlin, we have guests, and we also have all of you virtually from wherever in Europe you have just tuned in. Well, we see that the corona pandemic has changed all our lives, and we would never have been able to imagine all the changes. It is a stress test for our entire society, for the economy, for businesses, and of course for science. But I'm always optimistic, because first of all, we are not alone. Europe is a strong community. And that helps us to emerge from the crisis more resilient than ever. And secondly, we have strong research assets. And research is an important key to solving the major challenges of our present day. It was only a few weeks ago that we decided to reorient and strengthen the European research area. And thirdly, we also have a strong economy that is well networked with research institutions. Good ideas can thus be put into practice quickly, and only through innovation we can secure our competitiveness and our prosperity for the future, especially in difficult times. And fourthly, we should use the opportunities of technological progress. Our goal is to have a digitally sovereign Europe, and that brings me to quantum technologies. They are one of the cutting-edge technologies and disciplines for science and industry within Europe. They offer an enormous potential for our society. And quantum technologies makes it possible to have outstanding careers, both in science and in industry. With the Quantum Future program, and especially with this academy, we are focusing very clearly on the next generation, the up-and-coming generation. In universities and companies, in science and business, we can say that new technologies offer many opportunities which you can get to meet and know in this academy. Where will quantum technologies help us in everyday life in the future? What products can we have on the basis of this technology? The federal government has been funding quantum technologies in Germany and Europe for several years already. In this legislative term alone, we have provided a total of 650 million euros for application-oriented research projects. And here we worked with partners from industry and science. In view of the great dynamics, especially when we look at the international competition in cutting-edge technologies, we have decided on the level of the government to earmark an additional 300 million euros to specifically promote quantum computing. This will enable us to be right at the forefront of quantum computer technologies. And last but not least, we have just adopted a very powerful economic stimulus package in order to overcome the corona crisis. And there's a clear focus on education and future technologies. 2 billion euros were earmarked for quantum technologies alone. And that shows we are setting our clear-cut priorities. So this crisis is giving Europe a powerful push towards modernization, and we need that. Quantum technology and its numerous sub-disciplines are so complex that it is difficult to work alone. One country alone can never make it happen and work on so many different fronts, and therefore we need joint research efforts in Europe. It's all about Europe's technological sovereignty. It's about Europe's economic strength for the Europeans, for a good life in Europe. This new technology must benefit people, for example, through quantum sensor technology in surgery. For instance, when we look at the inscription of our data and when it comes to more precise models for climate change. Ladies and gentlemen, I am delighted to be here today, and it's wonderful to meet people that are enthusiastic about quantum technologies. Society is counting on you, and society is trusting you. Motivated students, committed researchers, innovative companies, courageous business founders. You all are helping Europe. For Europe to set a global standard for quantum technologies of the future. And your network makes an important contribution to creating a modern, sustainable and successful Europe. I would like to thank all the partners all over Europe, and I'm looking forward to an exchange with all of you.
Ganz, ganz herzlichen Dank, Anja Karliczek. Thank you very much for this first introductory statement that gives us the opportunity to open up to what needs to be done and what already has been achieved in that. One thing you mentioned was that you try in all the initiatives and all the activities, you try to start pretty young, let me put it like that. Why is that so important?
When it comes to artificial intelligence, we have seen that we just focused on research in the beginning in Germany, and only later we widened our efforts. And when it comes to quantum technologies, we like to start the other way around. We like to start as early as possible to integrate the up-and-coming generation in order to talk about how this technology can be translated from fundamental research to application. This is what we do differently this time, because we see that all these developments are happening much faster compared to what we used to have 30 years ago. So if we want to be in the lead, we need top research and broad-based initiatives to roll out technologies to business. We need all of that in parallel, and we need an interactive process. And this is why we are just focusing on the young generation now.
For you, what would you say? Okay, this is a good moment to be interested and to start.
It's never too early to get interested in science. You know, there's so many fields of application that one day will be part of our everyday life. Of course, you have to have some basic know-how. You have to have a basic understanding of physics. You need to have a knowledge about what quantums are. For somebody like me, it's not so easy to get a grip on it, but of course, those people who are interested in maths nowadays have a good basis in order to enter quantum technologies in the future and do some more in-depth work. And so we have to explain that to people. We have to explain that logics, maths, should be part of your everyday life when you're young, and that is required everywhere. The digital world is a very structured world, and this is where quantum technologies belong to.
As long as it's not just only zeros and ones as in a digital world. So quantum computing teaches us that this looks a little bit different and is much more open, and the age of 0 and 1 kind of is over. And my question goes to Dr. Markus Krutzik. You worked usually in a real setting here in this beautiful venue with a lot of people in this Quantum Future Academy. So this year, unfortunately, that has been a virtual setup. But still, my question, how did that go? What were the interesting things you came across? And maybe there were things that were even more exciting than being alive. So what is your experience about that last week?
Well, I can tell you that the atmosphere has been really excellent. So the motivation was huge. And, you know, to some of us, that was no surprise. Why? Because this year we had a selection of students from all over Europe taking place in the academy. And if you may say so, that was kind of the EU national team of quantum technologies, which we have been taking part in our academy. And the last 1.5 days, we have been sharing our insights on quantum technologies, our fascination on quantum technologies, sharing our different views on the applications and on the challenges. So what can you do better these days? But of course, we had our doubts, how good can we do this and how to make this a really useful and insightful event for the students. And we had great support by the VDITZ and the BMBF and a great local team from Ferdinand-Braun and Humboldt-Universität. And as far as I know and from what I heard, our, let's say, Quantum Future Academy in a nutshell, ranging from research to science communication to business models and back, resonated pretty well.
Is there something that where you said, wow, I had not expected this in particular, where I said, this is quite surprising or especially beautiful?
A lot of things. So one example would be that we had a workshop on business models from quantum technology applications, and the students have not been particularly prepared for this. And after 2.5 hours, they presented their ideas on, let's say, a company and what is the MVP, what is the value of the company, what are your competitors. So, and this was some transfer where I really thought, cool, I could learn the things from the students already.
If reverse mentoring is something I think quantum technology is working with pretty well, right? Because there are so many young people that come into that business, and there is senior people who look at them and say, wow, quite a good experience for that. What are your plans for next year when you hopefully can do the academy live again?
Well, we're all hoping, I think, for a more personal experience. So we want to have on-site visits of laboratories, of companies. We have been thinking about a quantum campfire situation with founders in the area of quantum technologies. We want to do a live experiment to verify how much of quantum technology is already present in our societies. We want to explore Berlin as a city. Not only it's a good city to live in, but especially a good city for quantum technologies.
Quantum technology, right. So let's hope we will see all of you together here next year in Berlin. Let me go and make my next question to Italy, to Pavia. And I'm absolutely pleased that we have a wonderful connection to Chiara Macchiavello, who is basically heading and chairing all the European activities that kind of are together or combined with research, education. Chiara, what in the ministry here in Germany has been planned, how does that relate to what is happening in Europe? What are your activities?
Well, in Europe, we are actually arranging quite a lot of activities aiming at different audiences. We worked on a research strategic agenda, which comprises the field of education, where we actually try to identify what are the needs for the future. We actually identified three main audiences because, education must be tailored to the specific audience where it's addressed to. So we have high school students and the general public. We have a university audience comprising bachelor and master students, PhD students, and also pre-service teachers that have to be trained to teach quantum technologies, and also a workforce that has to be prepared. So the specific initiatives have to be tailored to the specific audiences that needs to be addressed. And recently there has been the launch of dedicated coordination and support action in quantum education, where many activities will be launched and coordinated at the European level according to all these different audiences. Let me stress that here it is very important to have collaboration among European countries, because there are many national initiatives that are so far very fragmented, also due to the fact that specific competencies are not uniform all over Europe. So there is really a need to align the activities to identify and share best practices, education strategies, to shape new curricula in quantum technologies, quantum engineering, and this can be done only in a collected effort where all the stakeholders in Europe cooperate to this aim.
I'd like to.
So maybe I can.
I'd like to give back the question to Anja Karliczek as well, because this European coordination seems to be a key element in bringing quantum technology forward. Now, Germany at the moment holds the presidency of the EU. How do you align with what Chiara Macchiavello just said, and how do you can collaborate with these activities?
Well, for us, that's a very important topic under the umbrella of Horizon Europe, where we would like to be part of the game. But somebody has to make a start. Somebody has to be in the lead. We've seen it takes a long time. Now, after the election, we can really start developing new programs, and we have to sort of speed things up. And that is why it's wonderful to have the opportunity to use the economic stimulus package to start, at least in Germany. But what I said in the beginning is it's a common task for all of us. We need common standards at the end of the day. So the question of developing common standards is a question we will not be able to answer here in Germany alone. It's a question of how we reconcile, how we get together in our democratic world and say this is what we want, and certain other things we don't want.
To bring all that together into business, I'm very happy that Jan Goetz is here, because what you did, you did it basically. You not just did a doctor's degree in quantum physics, but you found your own company. And you did that in Finland, in Espoo. So how much more European can it get? I'm very curious about, how do you find the right people for the right tasks? How is it to set up a company in that particular subject? How does it all work out, and how can you encourage other young people basically to follow you?
Right, thank you. These are good points, and of course they're very valid for us. So when we started in Finland, the reason for starting there basically that we had a very unique combination together, starting from the technology, so there was research over decades going on in quantum technology there. Then we had the infrastructure part, so there is a production line there which we can use as a company. But then we also had a team in place. So we had a group of about 20 people who said, okay, if you start this company, we will start working with you immediately. And I think this is a combination you always need to start a company. On the team aspect, I would say, of course, there is a global shortage in talent, and this is something we all have to work on. Taking the European angle, I would say we are very well positioned in Europe in terms of the talent that we have here, in terms of numbers and also quality. So we have very excellent universities, and they're educating great people, so the next generations of quantum engineers or quantum leaders. The question is, of course, how can we in Europe sustain this and how can we make value out of it? And so for us as a company, for example, we expanded already from Finland to Munich, and we opened an office there. And one of the important reasons is that actually in Munich you have several excellent universities working in quantum technologies, and the talent is there locally. So this is something we have to see also on a global aspect. And we have to, of course, make sure that we keep the talent here and that it doesn't kind of leak away all over the world, and we don't have anyone left here. And I think in this sense, what we need to do is we have to also take away the whole responsibility for education from the academic sector, and we as companies, we have to take our own part, and this is what we try in IQM. So, for example, we have several professor-level people who work, and they are giving lectures. I myself, I'm giving lectures at Aalto University in quantum technologies in the bachelor program. I'm now giving lectures on quantum entrepreneurship at Technical University Munich. We are having PhD students in the company. We're having master students in the company. And I think in this common effort, if we are kind of providing the very attractive jobs or career paths on the scientific level, I think then we are very well positioned in Europe to go the next step and build an industry out of it.
So the idea of a dual study in quantum physics and working in one of these companies is not that far away.
No, it's happening.
Yeah.
It's right now happening. Yeah.
You said that in Finland there has been a couple of aspects that have been in place already for some time. Companies you could work with, academy that works well, and a long tradition of that. What would you recommend to other countries where to start?
Well, of course, you have to check what is missing in your country if it's not happening, right? And this is, I think, individual to the places, because we have actually all over Europe, for example, we have great infrastructure programs in certain places, and there are RTOs working, but then maybe the team is missing there, or maybe they're not working on quantum technologies. And I think you always need at least these three aspects. You need the team, the technology, and the infrastructure to build something, and everyone has to check what is missing in my place to make it happen.
How do programs like Quantum Future help with that?
Well, I think they help a lot because what they do is, and now I'm using physics slang, they entangle the worlds. They entangle, so they tie together the academic world with the industry world. So we have been now hearing that you have been talking about MVPs, so really business aspects. And I think we need more of these programs where actually scientists also talk business, and maybe the other way around. So we have already now business people in our company, and we teach them actually quantum physics. And I think this dialogue needs to happen if we really want to see the industry emerging.
Because then 1 and 1 is becoming 3, right?
I think that this natural translation, this natural link between business and science is something where we have to work in Germany. We need to foster that so that scientists can think, what can we do with the knowledge we have acquired? How can we use it in business? Sometimes we are too slow, and there's some countries that are much more advanced. We can learn from them. But this is what the academy here wants to achieve, this kind of natural translation. Many things get translated through the minds of the people, and we need to develop a culture of translating technologies right into business. But as you've said, we also need a feedback loop from business back to science, and that is an added value that will be very important in the future.
Just one of the activities you have planned and you've rolled out. So what over the next 12 months, 13 months, can quantum technologists and physicists expect? So could you make us some appetite on this?
Well, we started in 2018 already. We developed a framework program and we earmarked the first funds. And this was the starting point where we said, okay, over a period of 3 or 4 years, we are going to spend 650 million euro in that field. Now we added some more capacities. We said we need to be more systematic about quantum computing. We need to be able to look at the different technologies, fund the development in order to be able to build different quantum computers at the end of the day. So we said we need more money for that. And then all of a sudden the crisis hit. A crisis is always an opportunity as well. And now we have the economic stimulus package that gives us the opportunity to invest a huge amount of money, where we say, okay, we want to develop our own quantum computer. We will be in that process until the computer is finally ready to go. And that's a dimension we could not have managed with the smaller funding programs. Now we have a major opportunity to show that this is where we are in the lead, and that is the substantial change that became possible because of Corona.
Weitere Aktivität, die da so gestartet wird,
Another activity that is started is the process called quantum systems.
Spielt der darauf ein? I'm sorry, I can do that in English. You know, this is sorry.
Well, the agenda process is supposed to be a roadmap that is implemented in science. So it's not the clear-cut translation for the business use. This roadmap describes the process that is to happen in the field of science, in the academia. We are just in the beginning. I always compare to artificial intelligence. 30 years ago, nobody ever talked about it. Today, nobody talks about quantum technologies. It's something that is just known in a very small community, but we have to develop quickly. We have no more 30 years to go slowly, and that is why we have to intensify research.
Jan Goetz said something very important that I think is basically important for all the different areas. And I would like to start with Chiara to comment on that. When we want to keep scientists and entrepreneurs within Europe, what is the most important thing we need to do to keep people here and not moving to the US constantly and being there forever, or going to Asia or Israel?
Well, I think that it's important to create a very dynamic, active ecosystem where we have collaboration between research, academics, between industry and education experts. And in particular, it is important to, to communicate, to convey the message that it is possible also to have entrepreneurship initiatives in this field for the future. And I must say that Europe, from this point of view, has a very, let's say, position in this, because research is very strong. Basic research is very strong, and I think that this is really a main ingredient that has to be kept, especially if we think about progress in a long-term vision. And so this is something very important. It is important also to foster, as was said also before, the links with industries that in many parts of Europe are not so strong. Not only, well, you said that this happens in Germany, but in many other European countries there is these problems. But creating all this very dynamic and active ecosystem, I think we should really have the possibility to keep young talents here. And let me also say that it's very important, as the minister also stressed before, to have this early access to quantum technologies. So it is important to develop programs, education initiatives aiming also at secondary school students. An example of this was done at the European level, is within this European Quantum Week, where we organize this activity aimed at secondary school students and general public, where we introduced the concepts of quantum science and quantum technologies. And this was really successfully done in really a collaborative and cooperative effort among various European countries. Here, in order to maximize the impact for school students, it was important to deliver these introductory lectures in the native language. So these activities were organized in each national country in the native language, but it was very important to see how cooperation among countries leads to these very successful events. I mean, during this week we had these presentations with really thousands of students following. Right. And this is also an important point where we would like to coordinate activities at European level.
Much more in this. Markus Krutzik already said, we like to attract them to come to Berlin. It's a beautiful city to be here, and in terms of the academic background, you can find a lot of here. What is your scope and your point of view in how to keep scientists and entrepreneurs that are dealing with quantum technology in Europe?
I think a couple of things have been said already. So to come back to a point earlier on, I think the prerequisite is here. It's there, not only in Berlin, but in Germany. We have excellent universities, we have excellent research institutions, and we have industry. But I think it is to work on the interface between these institutions to allow a continuous transfer of knowledge between these institutions, and therefore, enable the students of the next generation, which have, let's say, a broader experience, not only in quantum science, but in business, but also in social aspects. So I think it's about the full package. I mean, we have a great package here, but now it's about to really make the students aware that this all exists. And I think that we can all work towards a more coherent demonstration of this.
Yeah. So Jan Goetz, you already basically made it happen. You are one of these success stories within Europe that said it is possible. What are your views on how to keep scientists, how to keep entrepreneurs in Europe and not making them go away to Stanford?
Yeah, I think what also this discussion nicely shows is a little bit the ambition level. Because for me, it's not important to keep people. I actually want to grow. I want to get people coming back to Europe, and this is what is happening. We are hiring from Australia, from Asia, from the US. And the question is, why are these people coming back to Europe? And I think something that we are underestimating a bit are the European values. For them, it's not about the money. They maybe earn more in the Silicon Valley. It's really where do they want to live and where do they want to grow their families? And I think there are three aspects in terms of quantum computing and European values actually play well together when you really want to grow a healthy business. One is that we are very honest. We are not over-promising everything and say quantum computers will kind of save the world, right? This is not the way of communication. But there are specific problems where the quantum computers help, and this is what we are working on. So being honest and realistic, actually, this is something I think that we have and we should keep. And then it was mentioned already, the collaborative nature. Also, we are not saying we do this alone and everyone else just go away, but we say, okay, we want to partner. We want to partner with maybe software companies, industry partners, academia, and we do this then in a joint effort, also with the politics and public institutions. And I think keeping this in mind, actually, we are not able to keep people here, but actually we are able to attract people to come back to Europe.
Yeah, so making Europe a very interesting place to work, especially the things that have been said on the German political level, let me put it like that, and on the European level, is that we need to integrate and work across branches, across industries, and across studies. So what would be your proposal, and maybe we start in Germany, what would be the best or the most important thing to tackle to get people from different disciplines together on one table, in one room, in one company? And then we go to Europe, but let's start with Germany.
Well, part of the task that we would like to solve with our funding program is to create a network between science and industry in an interdisciplinary way. And it's not just a phenomenon in quantum technologies. We see it everywhere. Wherever we talk about technology, we need that network. The different disciplines alone can no longer develop as quickly as they need to develop. And this is what we would like to trigger with our funding program, bring disciplines together in order to promote progress. So we always need a system of innovation. That is one pillar we try to keep well established. And then there are additional programs to bring people together.
And there must be programs that bring people together. So the structure is a basis, and then people. How is that really? How is that mirrored in Europe, Chiara Macchiavello? That these different branches, different industries, different professions people bring. How do we roll that out in Europe in a concrete way?
Yes. Well, let me stress that interdisciplinarity is really one of the main features of quantum technologies. So if we want to fully exploit the potentiality of quantum technologies in the future, we need to address several disciplines. So not only physics, engineering, computer science, mathematics, but also chemistry, biology, medicine. So, and this is also something that makes the field of quantum technology so stimulating and interesting. At the European level, so this effort, as I said, has to be done in collaboration with the various stakeholders, industry, education experts, academia, and policymakers. The idea is to do all this along different lines. So the first thing is to to construct a community that is able to collaborate on these topics and that comprises all these categories of stakeholders, of people, in order to understand and to provide a roadmap of where to go. Then it's important to provide an infrastructure service where best practices that are already present in many places in Europe. We have already excellent examples of this, can be analyzed, studied, and identified and shared in the end. So in this infrastructure service, it's also important to collect and share materials, teaching strategies, and innovative programs, new curricula. And on this, it's important then to align and to novel tasks. And in this, we are planning to identify some pilot programs in the different sectors that I showed before. So one of these main programs that we will be working at is a pilot program from an interdisciplinary master course. And here it is important to have interdisciplinarity and also the support of industries in order to organize internal internships for students in industry to foster the link with industries. There will be also pilots for other target audiences like high school students and general public, and also tailored programs for training industrial workforce. Also, people who are already in industry, work in business, but do not have a background in quantum technologies and quantum physics. So this is an additional line where we are going to work in a collaborative way within Europe.
I'd like to ask you another question that I will ask all the other participants of this wonderful panel. In January of this year, I was fortunate enough to participate in a workshop on quantum computing. I have no idea about this, but we were able within 2 hours, under the guidance of a gentleman who works for Google, to develop ideas of applications. So what we came up with in 2 hours, and again, I'm absolutely no expert in this, by no means. We were coming up with a weather application that worked faster, and we came up with something to learn in different language in a different way. So this was something, again, we were all, for us, we had no idea. For us, it was very easy to do. So what is the first practical application where you would say, like, yeah, this is something we are going to see on the market pretty soon, and with soon I mean 2-3 years, and this is going to be a question for all of you. So what are you looking forward to see? Chiara?
Okay.
I start with you.
Okay, yes. Well, this is, there are many possible applications in quantum technologies. So, for example, if we think about let's say, a near future, we will have secure systems for communications to achieve transactions, e-commerce, and also to transfer and store medical data in complete security. Then more on the side of computational problems, the advantage of quantum technologies is the possibility of predicting the behavior of complex systems. And this can have applications in, areas such as traffic regulations, optimize logistics. Yeah. And in particular, this is also something that I think would be very interested and impactful in the future, to design and develop new chemicals and new materials. Other areas are, of course, in the realm of high precision sensing and measurements that could be beneficial for new medical diagnostics, and also for high precision navigation systems. So these are some examples, of course, I think that even more applications, more benefits will come in the future that we cannot even think about now. No, so these are
beginning. It's a very good beginning. Especially
it's just the beginning.
Security things, high precision and high predictability. The high predictability thing that was at this Google workshop, something we did with the weather things, right? And we were highly astonished how fast it went. Jan Goetz, you are basically closest to a product, what we would call a product, right? Like a computer. So how does that look for you? What is the applications? What is the product side? What do you envision and see?
Yeah, I think to understand this a little bit better, first we have to kind of understand that there are 3 pillars in quantum technologies, and it's not all about quantum computing. So there's quantum communication, it's already very advanced, and there are companies and products on the market, and then there's sensing as well. And now many people talk only about quantum computing, which I don't complain about, because this is, of course, the business of our company. But if we stick to the quantum computing, also there, I think and it fits very nicely to the discussion topic here today, is that the very early machines that we will see, they will not be used to solve the biggest business problems, but we will use them to do education and research. And in this way, it's kind of a self-amplifying process. We will use them to educate more talents, they will build even better computers. And then, after a few years, we will reach a threshold, people call this quantum advantage, when this machine can actually solve business problems. But in the next 2-3 years, we will use these machines to educate the next generations of quantum engineers, mainly.
You must like that a lot, educating in a way that the system is getting bigger and bigger, and then this threshold is developing, right? What is the application you expect most? What is the thing you're waiting for?
Well, we see we have developed quite a few technologies. When we talk about quantum sensors, we have just read in the newspapers that the first products are entering the market now. This is something tangible. And as my colleague has just said, it will take some time for some other fields of application. But for me, the most decisive thing is not to see the first thing happening. For me, the most important aspect is to make progress both in the field of science, accelerate processes and research, and make it possible for the next generation to utilize these results. We are not deciding what is best and what is happening. We want to enable people to accelerate work in all fields, quantum sensors and quantum communication technologies. These are just single products, but there will be many products in the future based on that technology. And so we need new products, we need business, so we need to sell new products. But secondly, we always have to think about what we need to do. What are the problems we need to solve, like climate change? And in the field of climate change, we've got so many open issues, complex problems that are not yet solved, and they need the capacities of a quantum computer. We need quantum technology urgently in order to be able to solve our urgent problems soon. Problems are getting bigger and more complex, and we have to have access to quantum
anyway,
technology.
That brings us forward in a very fast pace, right? And looking to that from a science perspective, I mean, this is basically you look what can be enabled and what will be just a theoretical idea. This is what you do every day in the lab. What is the thing you already taste where you say like, oh yeah, if you could do this, we would predict the weather report, or is it something completely different?
Well, there are many things, and also interacting with students, or especially young students, you also, as you said in the beginning, you get challenged about ideas and new ideas. Are they actually realistic? Can you do them? Can't you do them? So that is already a very good environment for us. But coming back to also one of the points discussed earlier is that how do we motivate people across disciplines to join this field? And I think the most important part is to provide solutions to problems. And then people can identify. If you say, I have a cold atomic cloud here in my laboratory, then quantum physicists say, that's interesting. If you want to raise up your cells, then you get the people from business. But if you say that you want to build a quantum computer to optimize traffic flow, to reduce, for example, CO2 emission, then you get the excitement of all disciplines.
Everybody.
I think that's very important. And this is something we can taste, especially in our scientific or university environment, getting in touch with all of these students and all of these ideas. And I think most of the, or some of the nice applications already have been mentioned, from healthcare, from better diagnostics, from measurable security, digital patient records, how do you transfer them? Quantum simulating for precision medicine or navigation. We have better clocks for more precise determination of our position, but we also have solutions how to navigate in areas where you don't have a GPS system. And this is just for us very motivating to see these ideas coming up and to try to answer them in the laboratory.
So the more success stories, the more integrated cases we can build, the more people will be attracted to that. Then it's developing like a kind of a point of gravitation from all the different disciplines. Right? I'm not a physicist. I'm a language scientist. So that maybe helps. I do have a question to Jan. In people who would come from the business side and say, you know what, I do not study. I'm an entrepreneur. I want to set up my own business. But I think this is an interesting field of operations. What are the biggest stakes? What are the best recommendations you can give to these people? Want to set up their own shop, but do it in a way that supports quantum technology.
Well, again, I think it's a team effort. So also in my case, I'm not the only founder of our company, but we are 4 people. And during the whole process, actually, we always had a great network of people who have advised us. And I think even if you're not coming from the quantum technology side, you can still start a quantum business, but maybe then with the correct partners. And then you have already from the start this mix of business ideas and technology ideas. In our case, actually, we were 4 physicists scientists. So we were completely missing this business aspect, the legal aspect, the finance aspect, right? So we had to get the right people on board then in the beginning. So I think it's more being curious. So if you want to start something and you say, hey, I have this great idea, and then maybe ask the right people, would you like to join? And then you do this together. I think it always works, no matter what background you have.
Yeah, so be inviting in whatever you do. Be open. This is what I hear from all of you. Do not close down the shop in a sense of, no, I'm doing my own thing, but more like, hey, I have something very fascinating. Would you like to collaborate with your specialty on this? Because I think this is the most important thing, that we are inviting, because the more people think about something, the better the result will be. My last question to all of you goes to something that I think plays a more and more important role. Now at the moment, we are surfing on a wave of hype for quantum techniques, technology, computing, sensors, all that. How do we turn Europe-wide in Germany, at the university and in business, how do we turn that into something sustainable? That people do not think, yeah, 2 years back we had this quantum thing and now it is gone. Let's start with Chiara. What is necessary to do that?
I think to do this, as I also said before, partially, it's important still to keep very strong the basic research direction. So it's very important to keep this curiosity in exploring new phenomena and in answering still big questions that are still open, also in the theory of quantum information that underlines quantum technology. And so not only focus on the applications, on the market products that are important, of course, but still keep this curiosity and this motivation to understand really the basic phenomena, even if at the moment we don't see immediate applications to everyday life or to the market.
Yeah.
I think this is important.
Curiosity is a never-ending thing, right? It's eternal. Curiosity is probably one of the most sustainable things we have, and it starts on a very early age, right? It starts when you're a very, very, very little child. You're curious about your surroundings. So let's keep our curiosity. That is something I take from what you said. Thank you. Markus,
I fully agree. Keeping the curiosity, especially in the university environment, I think is somewhat natural.
Yeah.
And I think the universities, they will survive any hype of quantum technologies because they do basic research. They are curious on several aspects of physics, how everything works together, how our world, actually our universe works. So, and this curiosity will stay there independent of any application trend, you might say so. I think making it sustainable, again, coming back to the applications and the problems we solve. This is what we have to face together with the research institution and with the companies to really identify what problems do we solve. And then the products, they will just be there if our technology is up and ready. And this is my last point, is that besides all the curiosity and the applications and the problems we solve, we also have an eye on, okay, what technologies do I need to really produce a very robust and compact and scalable system, which I then can basically sell.
Yeah. So looking out what is needed helps a lot. Being curious, this is the first point, look to what is needed. And Jan, what makes it sustainable in your perspective of next 10 years?
Yeah, I think this is an important point, because I think we all have to be very careful not to create a bubble that then just explodes, right? And this is, for me, it's expectation management. So you make promises and then you deliver. For example, I've been in communication with people from the European Commission now for quite a while, and recently Ms. von der Leyen was actually publishing in her State of the Union the roadmap for Europe. Yeah. And I think when you read this carefully, the milestones now in terms of quantum computing, for example, they're very realistic, and there are several startups in Europe that can deliver on those. And I think if we do it this way, that basically there's a good communication between politics and then the industry, emerging industry, and we keep to our promises. I think it will not be a bubble, but maybe it takes a little bit longer than some people think, but still it will last. I think this is important too.
So we have the curiosity, we have looking out what is needed, we have the communication and trusting what's going on. Last word, Anja Karliczek.
Well, first of all, the more we know, the more we know what we don't know. And that always helps us to develop further. This is not only true for science. At the end of the day, it's also true for every problem we need to solve. As it was just said, we were thinking about a long time, do we have climate change, yes or no? And now we know, yes, it's anthropogenic and we do have climate change. 10 or 15 years ago, we wouldn't have said that. And we started understanding our own human influence on climate only fairly recently, and the more we understand, the more we see questions on the horizon we do not know the answers to. And that is the very process of innovation. Innovation must go on. And I also would like to mention something else. I'd like to focus on sustainability. When we see there is an added value, then it's quite clear that sustainability will be there. Maybe one day we will not be so fascinated about quantums anymore because they have become part of our day-to-day life, but still developments will go on. Many things where we say today, well, it's an old technology, but we still see some room for improvement. And the same thing is going to happen to the quantum technologies. We are going to see new things time and again. So I'm very confident about innovation that will always go on.
Can use, right? So let me summarize that. This is just the beginning. Right? This is just the beginning of hopefully a very, very great development that brings this technology, this industry, and the applications it will bring to make human life better on Earth, hopefully within the next 5 to 10 years, to markets, let me put it like that, to markets and to people, because in the end it's people who talk about things and markets and ideas and bring them back and let them exponentially grow. And this is what's needed, exponential growth of exactly these quantum technology ideas. Thank you very much for being our guest today. I hope it was inspiring for the audience. This afternoon, for everybody who is interested, we are awarding a Quantum Future Award for the best quantum ideas. So, and it's pretty much going to be an exciting thing. So if you want, join us at 3 o'clock on this channel again. Thank you very much, Anja Karliczek, Chiara Macchiavello, Jan Goetz, Markus Krutzik. Thank you very much for being here.